Because in this case, the k is a single value, right? So in k space, only a sharp line. The height of this line is magnitude of the wave. But as I mentioned, because this wave occupies real space in chi space, we are not able to use this wave to replace, to stand for a particle, right? A particle must occupy a certain space. So we have to cut this wave short. But if we cut this wave short in k space, you must have a distribution, broad distribution in k space. Okay, now I gradually increase components. You see, if I introduce two more components, and in real space, you see the wave is modified. If I introduce more components in real space, this wave is modified. But however, although the wave is modified, the wave becomes impulse. We have infinity impulse. How many? I don't know how many. But however, although this wave is not a perfect wave, this impulse is repeated. It's a periodic impulse. In k space, for this kind of situation in k space, I have 5 components. But we are not able to use this impulse to describe a particle, right? What we do is we have to introduce more components into the system. Okay. You see, if I introduce more components and the gap between the impulse becomes bigger, further increase. This is not sufficient. I don't want other impulse. I only want one impulse to replace a particle, right? What I do is I have to introduce many components, you know. It's not sufficient, and eventually become a continuum. Once this k space continues distributed in real space, I have only one impulse. This impulse be able to stand for a particle, be able to represent the particle. And this wave, we have to understand, in real space, you have many waves added together. In k space, those wave k distribution is this. Actually, you have many components k. In real space, you have delta x. In k space, you have delta k. Remember, delta x plus multiplied by delta k is nearly equal 1. Now, I reduce this. You see here, I increase this delta k. If I increase this delta k, you look at this width. Very fine. You see, I increase delta k, delta s can become smaller, right? I reduce delta k. If I reduce delta k, delta s become bigger. I further reduce. And I further reduce. And I further reduce. Right. If I reduce delta k, delta x will increase. If I increase delta k, delta x will increase. So the product delta x, delta k is nearly equal 1. Okay? This is a very important relation. I hope through this demo I establish this picture. So we have to back to the lecture now again.